morning. Good morning. Please have a seat. It's time to start. Well, good morning. It's really a pleasure for us to see so much people here today. We had, in our opinion, a very success because we had more than 450 registrations and nearly 150 people here in presence, which is a very good result if we, due to all the difficult situation that we are facing in this period. So, my name is Alessandro Fortunato, and I would like to say welcome to all of you for being here. And now I think it's time to start, and I'm really happy to introduce Stefano Cattorini, which is the General Director of BIREX. Stefano, thank you for hosting us and for the great job you did, because in my opinion, one of the reasons of the success is the very good organizations of you and your team. Please, Stefano.
Good morning, everybody. Thank you very much. I think it's with a bit of emotion that I see a lot of people here after a while, and I will start sharing a thought to Cavalier Golinelli, who recently passed away, as probably most of you already know. He was a real innovation maker, and he was the one who thought 30 years ago a place like this, like Fondazione Golinelli. And I'm sure he would have loved an event like this based on networking, open innovation, technology transfer sharing. So I'm starting with this. When it comes to myself, I'm Stefano Cattorini. I'm the General Manager of BIREX Competence Center. Briefly, who we are. We are one of the 8 competence centers created by Minister of Economic Development 3 years ago. Basically, we started our activities formally in December 2018. So we just celebrate, I would say, 3 years of activity. We are a public-private partnership. So we put together the best of academies, leading by University of Bologna, the best of research institutes, like Cineca, INFN, to mention some of them. I will go after that. And the best of industry, a good combination of end-user innovators and technology service provider. And I think an event like today is a perfect example of this interaction. Our mission is basically, we have 2 missions, I would say, to help enterprises, companies, to move them, to let them understand the benefits of Industry 4.0 technology, to understand, to adapt, and to use them, in particular small, medium enterprises, and to help companies and academies to share practice and to do a real effective technology transfer. Our partners, this is the real added value, I would say, that BIREX is trying to stimulate in some way. As I said, 56, but since December, we open up the consortium, and I can tell you and sharing that we are already 60, I would say. So already new companies are joining BIREX. This is a perfect mix of, as I said, public institution, the excellence of the research we have here, together with the excellence of academy. All the 4 academies of Emilia-Romagna region are in BIREX. 27 end user, let me say, also a sort of lead by example innovation, who understood one simple key mission of BIREX, to bring together with them their filiere, their subcontracts, the subcontractors of the subcontractor. This is crucial to share the innovation also to the small, medium enterprise. And then the technology service provider who are putting in BREX their competence, their solutions. I will mention this, of course, Assessore Colla will probably is much better than me in explaining this, but I will simply saying that BREX is fully integrated in the Emilia-Romagna ecosystem, what is now called a data valley. Here you can see, I will not mention them, the list of important project, solution, competence that is going to be injected and is already there in some case in the Technopole of Bologna. I think what is crucial is any of these key players can combine with his specific mission. And as I said, BREX in a simple way is a technology transfer player. I think also that when it comes to times like that, today we are facing a huge amount of complexities. It was already there with digital transformation, the pandemic, and now the war with all the impact of the economic environment required ecosystem of collaboration. Nobody, even the best company, can do that alone, can face with this complexity alone. What we do is simple, I would say. So we build up a set of services in order to orient. This is, for me, a perfect example of an orientation workshop. So where we offer, basically for free, the possibility for companies, academics, end user, technical service provider to share practice and to think about innovation. We have a set of services, training, consultant. We also we are basically getting most of the public co-financing we got from the Ministry of Economic Development. We are redistributing it to companies. So basically we issue formal auction for industrial innovation project, a sort of collaborative public-private research project. We finish, I would say, the first 3 years programs, and we are starting now discussing with the minister a second 3-year track. Then we have our structure. So just behind this building is BREX Competence Center, which I invite you during these 2 days to visit, in particular to our pilot plan, a real Industry 4.0 production plan where all the 4.0 technology are digitalized and interconnected. I think this is the real core of the competence center. What is becoming crucial for companies, in particular for small, medium enterprises, is to have the possibility to test technology before making investments. Our concept of pilot plan is a real smart factory where company, professionals, researchers work all together in a real production area. We can produce over there, but without the limit of a production. So you can make innovation, you can change parameters, you can play, let me say, with a production plant. So this is a perfect test before invest production plant. We also, over there, support the innovation project that we are co-financing. And last but not least, this is also a crucial asset for all our training courses. So to have a real hands-on area that combine, let me say, the academic and the company's training. Just to give you a view, but again, my invitation to all of you in these 2 days is to visit us. Our team will be happy to share the technology area. We have also a laser technology, since here today, in these 2 days, we are gonna thinking about laser application and their impact on the manufacturing industry. We have some solution there in what we see in the left part of the slide. So we have 2 technologies, a selective laser melting and a direct energy deposition machine. We have also an area dedicated instead to plastic additive solution. We have our collaborative and non-collaborative robotics that can be think like a sort of automation, logistic kind of application example. We have the measurement part, the scanning and measuring. We have the network control center with a huge machine in order also to combine, let me say, traditional advanced manufacturing technology with additive metal technology. We have all the cycle that we can show there and use there. But the core at the end of the day is the edge computing and the cloud analytics. BREX is the competence center focus, among others, on big data. Our goal there is to take the data starting from our plant, make analysis, and show to companies how the storage of data, the analytics of the data can be used in the process, in the pre-production, in the post-production process, in designing, in creating efficient model of predictive maintenance and business model based on data analytics. The center is also, we have a 5G private network, which allow us to develop POC and use cases based on connectivity, on fast mobile connectivity like 5G. We started already to develop few IoT, industrial IoT POC, but of course this is like a new really technology. At the end, apart from the marketing announcement, 5G is starting now, and industrial IoT companies need to understand the benefits. Over there, they can test some of them. Last but not least, our pilot plant can be thought as a, let me say, a node of a much bigger innovation center, federated technology, let me say, alliance almost. So we are trying to interconnect our capabilities and our technology with innovation center that our partners are giving us some way the availability to use towards especially small medium enterprise. I can mention for all Cineca Lab. We are already working with Cineca since more than 1 year to develop HPC as a services model, to let also small medium enterprise understand the benefit of high performance computing technology to treat a huge amount of different data. With that, I think I close here. A warm welcome again, and enjoy this today's workshop. Thank you very much.
Thank you, Stefano. And we have a small modification of the program because we are honored to have here Assessore Colla, but he has other business, so the next speaker won't be Professor Liverani, but Assessore Colla. Assessore Colla is the Counselor for Economic Development and Green Economy of our region, Emilia-Romagna. So please, the stage is yours.
Grazie, e vi risparmio il mio inglese, però volevo essere qui perché intanto voglio ringraziare il gruppo dirigente, la struttura di BREX che stanno facendo un lavoro splendido e lo fanno con un competence center di grande qualità, ormai stiamo parlando di un competence center del Paese di livello internazionale, di una rete internazionale, e acceleratore, laboratorio, e start-up, e academy, e competenze, saperi e relazioni, ma c'è un punto di grande qualità in questo competence center in BREX che è la capacità di tenere insieme le teste dell'accademia con le teste dell'impresa. Questa amalgama è l'amalgama che ha fatto la regione, una grande regione manifatturiera che sta nel mondo. L'Emilia-Romagna sta nel mondo o non è? Questo è il tratto fondamentale.
Thank you very much. I'll spare you my English. In fact, I'd like to thank you for inviting me, this group of BREX, and what they're doing. In fact, they're doing a splendid job with their competence center, which is working at international level In fact, they have an international network of accelerators, of the Academy of Startup Enterprises, and it's a real point of quality in our region with an enormous capacity. And in fact, what they really do, and which they do so very well, is they put together the heads or the brains of the academic world with the business world and companies. And that's a really winning amalgam. In fact, this is what has made our region of Emilia-Romagna a manufacturing center for the world. And in fact, our region can only be part of that sort of world business.
Grazie, volevo capire se le traduzioni erano competenti a B-Rex, devo dire splendide.
I want to see whether I was translating properly.
E l'altra cosa che vi voglio consegnare da questa regione, volutamente sono voluto essere qui, lo voglio dire all'impresa, anche alla mia gente, pur vedendo delle foto incredibili che mai nessuno avrebbe voluto vedere. Noi non ci possiamo permettere di fermare gli investimenti, non ci possiamo permettere di fermare la ricerca, non ci possiamo permettere di fermare la manifattura. Per quanto ci riguarda, non saremo scalfiti da quelle fotografie dal punto di vista del ruolo istituzionale nell'essere di supporto a tutti gli investimenti che abbiamo di fronte e che abbiamo programmato. Non arretriamo pur sapendo della sterzata che è in atto e che ci farà riflettere sulle filiere, sull'energia, sulla capacità di ridisegnare le filiere, anche una nuova autonomia, un nuovo reshoring, una nuova idea anche di energia nel nostro Paese.
Allow me, there's another reason why I'm here to speak on behalf of the region and why we're here. In fact, this is something that I would like to underline. Even if we've seen those terrible photographs, and we must not stop in our investments, we must not stop in what we're doing in research, in manufacturing, and we must not allow those photos, in fact, to in any way damage what we're doing. And we must continue to support our research and the programs that we have started. And so even if that means that we're going to have to take a new tack with regard to the supply chains and redistribution, even if it means a different sort of offshoring or even onshoring, we still, in fact, cannot allow those photographs to in any way influence and impact what we're doing and what we continue to do.
Quella tecnologia laser che presentato è una tecnologia splendida, importantissima nel settore della manifattura, che tra l'altro fa risparmiare anche molta energia. E però dalla dimensione del ruolo che noi vogliamo giocare in questa regione. La regione ha bisogno del suo paese, vuole aiutare il suo paese e per ogni di questa tecnologia abbiamo bisogno di avere la digitalizzazione. Avete presentato il Tecnopolo di Bologna, quello è a Bologna, ma è il Tecnopolo dell'Europa, il Tecnopolo del Paese.
In fact, the laser technology is, of course, a splendid technology for manufacturing, and also, by the way, it saves an awful lot of energy. This is the dimension and the size of the role that we want for our region, but our region is, of course, part of the country which we intend to support and help. And any technology, in fact, however, has to be part of the world, and we need more digitalization, as in fact we see coming from the technical pole, and this is the road that we have to go along.
In quel Tecnopolo avremo il più grande computer in grado di studiare in forma preventiva il clima, quindi prevedere le catastrofi, riuscire a prevedere cosa avviene in Europa e cosa avviene nei nostri territori. Penso che sia un fatto eccezionale, è in grado di fare previsioni incredibili. E poi avremo l'altro grande supercomputer Leonardo, che quello è un supercomputer proprio che avrà relazioni con tutto il sistema manifatturiero. E poi avremo il più grande investimento di ricerca dell'Enea nell'economia circolare. E poi sapete che abbiamo fatto il più grande accordo con la firma del ministro con CNR, perché il tema dello studio dei materiali, stiamo parlando di tecnologie abilitanti per tutti. Questa regione è una regione che è in una situazione splendida dal punto di vista di essere in relazione al sistema dell'impresa, la conoscenza e l'università, e volevo essere qui con voi per dire qui a BIREX l'importanza che hanno iniziative come queste in presenza, e dobbiamo continuare ad andare in quella direzione e dobbiamo fare alleanze con gli altri, con le altre università, con le altre regioni, con gli altri paesi, con le altre nazioni, e avere un'idea di pace. La pace regge se regge tutto il sistema economico, culturale delle relazioni che abbiamo in questa grande regione. Grazie.
And the technopole that we have here, of course, is something which is quite splendid. We have the most important computer, which will allow us to forecast the climate and possible catastrophes, what's happening in our country, what's happening in Europe and around the world. And that is quite an exceptional achievement. And then also we have the supercomputer Leonardo, which links in and has relations with the manufacturing basis. And also we have the investment of INEA with regard to the circular economy. And also there's the agreement which was signed by the minister with the CNR, which is the National Research Centre, with regard to studying materials. Of course, materials which will be applicable to all sorts of technology. And this, in fact, is the point of excellence which our region has, and it's a splendid point of excellence because, as I said, it brings together companies together with universities. And that is what we have, in fact, here at BREX. And it's very important that BREX develops events like this in the presence of people. That's very important because we have to continue our alliances with research units, with universities, and with other regions and other parts of the world, because that's the way that we can develop peace. And if we have peace, well, then we can forge ahead.
Grazie ancora, e permettetemi solo in chiusura di ricordare ancora Golinelli ci ha consegnato una cosa splendida, un imprenditore eccezionale, e voglio portarvi anche il saluto del Presidente. Siamo in una sede per noi anche di grande emozione morale, valoriale. Grazie veramente.
Thank you, and I'd just like to end by saying a few words in memory of Mr. Golinelli, who was a splendid entrepreneur and gave us this wonderful seat. He really was an excellent entrepreneur who foresaw so many things, and it's thanks to him that we're here also. And I'd also like to bring the greetings of the President of the region. Thank you very much.
Thank you, Assessore Colla, for your very interesting and inspiring speech. And let's move to the next speaker, which is the director of the department, of my department, Professor Alfredo Liverani. Thank you for being here and to present also the department where we work and where we do all the activities that we will present in the next days. Please, Alfredo.
Thank you, Alessandro. Good morning to everybody. I'm so pleased to show you something about our department that is one of the most important partners, academic partners of BREX. And there's the demonstration that academics, universities, and companies can collaborate together in a very good way. So, next one, okay. Our department has two locations, one in Bologna and not far from here, in some laboratories, and the historical place near Via LaserEMobility. And also in Forlì, where you can find didactical places and also laboratories for aerodynamics, aeronautics, and aerospace researches. Some numbers of our departments, just to make an overview of the complexity of this department. Teaching and researching personnel, 103 now, and in the last last 2 or 3 years, we had an increasing of over 10 units, And just to have an idea of the way to work and increasing the activities in the didactical and also in the research field. Administrative and technical personnel, 3D5. Fellowships, it is a large amount of students that after the bachelor starts working in the companies, or some of them are also working here in the BRX because the sharing of the knowledge is very, very high, very important. PhD students are 73. This is all the peoples that with different knowledge and different backgrounds are working in our departments in collaboration with BRX and companies. Some economical facts. The activities sometimes means also money that are used to increase the activities and the research. And you can see that this are a couple of numbers regarding also this, all this work that the department is used to do with companies and competence center. And this is only the money, the return related to relationship with companies. And most, a great part of this are used for equipments and positions for students after the bachelor in order to make them on the way of the research. Activities, didactical, yes. All the department is able to cover to make some around 20,000 hours, teaching hours per year, considering all the locations, Bologna and Forlì, 4 laboratories in 2 different cities, and a great amount of other activities that makes the student aware of the problems on the field. So with competitions and also learning by doing, that means they're involved in collaboration with companies, internship, and many other activities like thesis and so on. This is the courses that we are that the department is holding, mechanical engineering, management, and energy, and in particular on the 2, aerospace engineering in Forlì and another mechanics, and also an advanced automotive engineering that is a shared second degree bachelor shared with other university in the Emilia-Romagna. This is this is what we are talking about. In particular, this course is dedicated to automotive in general, but in particular in Bologna is focused on motorcycles. Well, employment. I'm really very proud because we can see that our students start to work in a company very, very quickly after the bachelor, and they are very appreciated. And I think that this is, for our products, means something really important and a great result. What about research projects? In this moment, the department is holding around 500 projects with different levels, from European projects up to small projects in the level of the local projects. But this makes a great amount of activities, and most of this is dedicated to technology transfer to companies. and this is one of the most important. Our name is Department of Industrial Engineering. Research fields are very different, various, very variable, from energy, management, machineries, manufacturing, of course, and engineering in general, design, and this is all the capacity that the department is able to make it into the industrial field. So, some colorful picture at the end, just to mention so only a little part of the collaboration that we have, and I think that is a very, very important thing for us to continue, and BREX is really a great place to increase and deepen these collaborations. Thank you.
Thank you, Professor Liverani, for the presentation of our department. And we can now have the next speaker, which is a remote speech, Professor Luca Settineri from Politecnico di Torino. He cannot be here, but he's... hi, Professor Settineri. Ciao, Luca. I can see you. And he's the president of Italian Association of Manufacturing and Technologies, which helps us in spread our activities throughout our colleagues in Italy. So, Professor Settineri, thank you for being here, and the stage is yours.
Grazie, Alessandro. Thank you, Alessandro. Thank you all, and congratulations for this workshop. It seems to me that the room is full, or almost full, which is, as you said at the beginning, a very good achievement and an amazing achievement, I would say, given the times. I'm sorry I could not be with you due to other businesses. And yes, as Alessandro said, I'm the president currently of the Italian Association of Manufacturing Technologies, which is a 30-year-old association that puts together research groups from all the country, from all over the country. Many universities are involved, and also research centers from public research institutions. We have several industrial partners as well in our associations, actually industrial associates, which actively contribute to our businesses and activities and events. The scope of the association is to promote the study and the development of knowledge in the field of manufacturing technologies and systems in all their aspects, such as, of course, transformation processes of products from the production phase to the assembly phase, testing and characterization of the transformed materials, methodologies and tools for designing the transformation systems as a whole, the processes, the components, the management and control of the production phase, the assembly, testing, recycling also as well. So it's a very wide range of technologies that we address. And we promote events and actions for fostering and disseminating the knowledge within the manufacturing sector. We do this within the association or in collaboration with national and international partners. We organize conferences, we organize workshops, such as, of course, the workshop that you are in this moment. And we are organized in sections because, of course, being extremely wide, the range of technologies we address. We organize in thematic sections, which address all many let's say sets or subsets of technologies such as machining, composites and polymers technologies, additive manufacturing, micromanufacturing, sustainability in manufacturing processes, biomanufacturing, digital twin, joining technologies, and of course lasers and laser e-mobility, such as the section that has organized the workshop you are following. So we are playing, I can say, an active role in the fostering knowledge in our field, and I think we can play, and we are playing an active and important role, of course, also in promoting the economy of the country, given that Italy is a manufacturing country. So I thank you all for being here, for being in this workshop, and for participating in this workshop. And I wish you a very fruitful session. Thank you all.
Thank you, Luca, for your speech, and thank you for helping us in promoting our activities and our results. And maybe next time you can be with us. We really hope it.
I really hope so. I really hope so.
Bye. Bye. Thank you, Luca.
Bye. Thank you.
So the next speech is my speech, is the introduction of the event. And I cannot see the slide. Oh, this is the slide. So first of all, before starting, I really want to thank and to introduce the other co-organizers, because I'm not the only co-organizer of this event. So I'm really happy to introduce Professor Ascari. Please, Professor Ascari from my department, and Professor Demir from Politecnico Milan, and Dr. Kriegler from Technische University of München. Please stand up. Thank you. As you can see, this event is the result of the collaboration of these three universities, and obviously it's also the result of the collaboration between universities and companies. So, why we are here? I think that it's quite evident that we are probably close to a revolution in terms of products, because everything is changing. In particular, it's changing in car manufacturing. These figures, it comes from a very popular document, which is an IPCA document, which basically shows us that in the next future, probably we will not have internal combustion engine anymore, and probably in the next future, all the civil transportation will be done by means of electric powertrain. And also this figure probably show us the importance of this sector in the future. This is a forecast, and if you see that now we are in 2022, the forecast says that probably in 8 years, the demand and the request of electric power will be increased by 5, which is probably an incredible revolution. So it justifies why we are here and the importance of the transformation of our manufacturing sectors. And as you probably know, there are several projects in Europe. Most of them are still projects, but all the countries in Europe are organizing themselves for the production of this new power, electric power. This is a map of the gigafactory that will be probably built in the next future to satisfy the demand of electric power that we need probably in the future. Why in Emilia-Romagna? Why we start this seminar here in Emilia-Romagna? Because Emilia-Romagna is probably the only region in Italy where we have car manufacturers which are really transforming their production towards the electric vehicle. As you know, we have Lamborghini, Ferrari, Ducati, and Dallar, and probably I'm forgetting also some other smaller company. And here we are lucky because all these companies daily ask us for new information, new technologies, and this promotes the developing of knowledge, and in particular the knowledge that we can develop into the universities. But at the same time, we also have Muner. Muner is a consortium between all those automotive manufacturers, and with this consortium and the university, as Professor Liverani said before, we have already created a master degree program devoted for the developing of new knowledge in high performance motorcycles and cars. The next question is probably why lasers? Because lasers, we found this sentence which is which explain why laser is so important, because it is estimated that between the 17 and the 80% of all material processing in EV manufacturing can be done by laser. And if you consider the increasing that we are having, you can imagine how it is important, probably laser, the next futures. Laser is currently used for many applications in this sector. For example, battery tray welding, hairpin welding, electrodes. There are already several applications because laser is not the future. Laser in some cases is the present because the companies which collaborate with us are using laser nowadays in their companies. From technological point of view, laser has several advantages. Quality, flexibility, productivity, and in the recent year, also the laser manufacturers developed new laser sources which still increase the usability of those lasers in companies. And so, in our opinion, why the workshop? Because in our opinion, we have laser and optics manufacturers that already have new solutions which can be used in companies. And end users, at the same time, are willing to use those new solutions for customer satisfaction. And in our opinion, we now probably have the necessity to create a link between those new hardware and end users. And in our opinion, universities and research centers can develop, optimize processes, and also can facilitate the introduction of this new tool, because laser is sometimes seen as a new tool for companies. So university and research center, by teaching students by means of PhD programs, can facilitate, can help companies in using in the right way those new tools that are being developing in the last years. So, what we know from the other countries? We know that all the European countries are doing a lot of investments in these sectors. This is an information that I easily found from internet about Northvolt. You can see how big is this investment in research activities. And this is also what we know from internet, so it's public about what Germany is doing for promoting, increasing research activities and research development in these sectors. As you can see, the grant is huge, especially for Italy. So we hope also that in the next future, Italy and our regions can be the same of those European countries. So I don't want to lose any time to the seminar. We are nearly on time, so we do not waste time. And I would just closing my presentation to thank you again and to thank all the attendees which are following us remotely. And thank you again. And so I think it's time to move and to call the first speaker, technical speaker, which is Thomas Hofmeister from Coherent. Thomas, are you Here, please, please. Can you come here? Coherent is one of the most important laser manufacturers, so we are really happy that Thomas can present their latest solution. Thomas, please, the stage is yours. Sorry, 15 minutes, so we may have 5 minutes for questions.
Yeah. You stop me after 15
Yes,
minutes.
yes, I will do.
Okay, thank you very much. A warm welcome from my side as well. Thank you for having us here and giving us the possibility to talk about coherent and the laser technology. And how do I do this next? Okay, I want to talk a little bit about the challenges we are facing with the e-mobility and what the implication is to the laser technology. And I would like to talk a little bit of the fiber laser arm and bring a few slides of the applications that we are doing in our apps labs. So when we are shifting from the internal combustion engine powertrain to the e-mobility powertrain or e-powertrain, we are losing a lot of components, but we are gaining a lot of components. These components, as you can see here, have a quite impact on the welding, the joining methods that we are seeing there. So, for instance, we are seeing parts coming into the e-powertrain that increases the welding extremely. Just think about the battery modules, battery packs, or think about the hairpin welding for the stators. So there's a lot more welding all of a sudden that has to be done. Think about the welding length that is increasing in the e-powertrain. Think about battery packs, battery trays, cooling plates, very long weld seams all of a sudden. And then think about the weld depth that is starting to change from extremely thin material to very thick material. So here we also see quite a big of variety coming for welding applications. Just think about battery cells with very fine thin metals. Think about inverters with deep copper welding. So here we see a much bigger variety all of a sudden for these joining methods to come. Also with the e-powertrain, and this is very important also for the laser technology, is that we are all of a sudden facing more materials, a wider range of materials that is not necessarily very good for welding applications. For instance, we see copper coming, we see aluminum alloys coming, some aluminum alloys that are not meant for welding very good, but are designed into the components, of course, because there are various reasons there. We see aluminum, extruded aluminum, we see die-casted aluminum that is now part of these components. Then we see the similar material combinations that are coming up in a great deal. Stainless steel, of course, is increasing. High-strength steel, of course. Here we have a huge variety all of a sudden that is coming with the e-powertrain. And then coming with these materials and with these increases and modifications, there's a lot of other demands that are coming all of a sudden with these new components. For instance, all of a sudden we have to be gas tight. All of a sudden we have to pressurize these components after welding, and we have to have a very tight seam. We will not allow spatters on the parts. We have material combinations that are very challenging, that are not really meant for fast joining methods. We have components, just think about battery cells that are sensitive to heat all of a sudden, so you have to cope with these demands. So we have a variety of things that all of a sudden add to all these other demands that we see. So for the typical laser technology that we are used to have in the automotive business, The typical laser technology is not that is welding usually all kinds of steel components and stuff like that, is not really meant for coping with all these technologies. So when you can see here on the side, some of the things really cause some troubles, and we have to do something to cope with these challenges. So there's some means that we can do to meet these challenges. Of course, we can increase the laser power. Of course, that's a widely common thing that we see. You increase the weld speed, of course. We see a higher use of scanner optics. We see beam oscillation being used. So there's a high variety of things that you try to do in order to get these things in a better condition. We see different process strategies coming. We see that you have to understand the process, the welding process much better to really have a productive process. And we see various wavelengths coming to cope with these materials. Today I want to talk about one of these measures, and that's the beam shaping with the arm laser. The beam shaping here, we see ring-core combination. And yeah, I will show a little bit what we can do with this ring-core combination to use this to meet these challenges. So see if this works. So when we see the ring and the core working together, we all of a sudden have some effects when they are working together. And these effects we can use for these challenging materials and challenging processes. And how this is working, I will give you a little bit an overview. First of all, for the principal understanding, the adjustable ring mode or arm laser that we are having in our laser technology comes with a coaxial fiber that delivers two beams, a ring beam and a center beam, coming with the same process fiber in principle. And the special feature of the arm laser is that you can completely individual control the power of the core and the ring, or the center and the ring. And yeah, the combination of the center and the ring, this is the theory that we see over here. When we are going in this direction for the welding onto the material with the spot onto the material, we see the trailing edge, the zone 1, which is how it is shown here. The zone 1 is the leading edge that is preheating the material when we are welding. The center is forming the keyhole, the zone number 2, which is the typical keyhole welding. And the zone number 3 is keeping the keyhole open much longer and is stabilizing the melt pool as it still heats up the welding seam. So this is the theory to it, and what we can do with it, I will show in the various applications. Most important to understand is that we are delivering a variety of different fibers with the arm laser, and you can have this as a spliced version, a direct coupled version, and then we can have different diameters. For instance, what's very new is we call it single mode arm. This is the first in the row with a single mode in the center, 25 micrometers, and 170 in the outer diameter of the ring. And yeah, there's a huge variety. We have a new variety, which is the 5200 that you can see over there. That is marked new. The 5200 we see now on the market with a high demand in e-mobility applications. The advantage here is that we have a very good combination with 5200, but we can combine this with a fiber-fiber coupler or a fiber-fiber switch in comparison to the single mode arm that is a spliced version. So, and then last but not least, the 100-290 is also seen very often in automotive and e-mobility applications, as this, as this provides a bigger spot and also comes with fiber coupler or fiber switch. Okay. So, to show a little bit the possibility and the working together of the core and the ring, when we are here on the left-hand side, can you see that? Yeah. When you see this on the left-hand side, when we have the center welding only, we have a very turbulent welding seam on the copper. We are welding copper here, and we have made some X-rays lately. You can see, I hope you can see this a bit. You can see a very narrow keyhole and a very turbulent welding, and you can see a lot of pores being formed because you have a breaking or a gapping, closing the gap of the keyhole, and that is causing these pores to be formed. So with a normal center power, it's you can go fast, but you have the possibility that you have a turbulent welding and an uneven welding, and you might create pores. So when we have a core ring combination, or the center ring combination, we see the welding is much more relaxed, much more stable, and we see almost no spatters here. And when we look at the X-ray down here, we see a much bigger open keyhole, and there's almost no pores being formed, and we have a very relaxed welding combination. If we do the other extreme and only weld with the ring alone, we see again that the welding is very turbulent, and you see here now spatters coming. The keyhole and the X-ray is not as deep. It's more open, but you can see here, it's very turbulent, and you will create spatters. So the correct combination of the power between the core and the ring is essential here. This is something we have to figure out exactly for your application, and exactly this is what we are doing in our apps labs to help you together with our technology to bring together the right parameters in this regard to have the best results for you as a customer. One of the features of the arm laser is that I mentioned this earlier. We can completely independently control the core and the ring, or the center and the ring from each other. This has some advantages, so we can use these effects in a certain way. For instance, when we are welding copper, what we can do is we are heating up the material, the copper material, and then we are ramping up the center. So when the copper material is heated up with the ring first, we increase the absorption for infrared laser, and then we can bring in the full power with the center and then weld it. As you can see here on the right-hand side on the graph here, that is the ramping of the two independent power of the beam. One time the ring, so we start with the ring, that's the blue line, and then we kick in the center once the material is heated up. That of course this is a slow motion here that of course works much faster, and you can see that we can have this is a controlled weld spot. It doesn't spatter, but we can definitely heat up the copper to have a very good absorption here. Yeah, this effect helps us with a very good starting and stopping of a weld seam. So we can reproduce this process every time with this ramping up and down, individual ramping up and down. As you can see here, the starting point, the end point is always the same. There's no difference there. And also what we can do for the starting point of the weld seam with the powering up the ring first and then powering the center, we can do it the other way around. When we stop when we stop the weld seam, and we avoid a pore or a crater at the end of the weld seam. Also, we are very sensitive to different surfaces. We have sanded here one of the sides, and the other side is polished. So nevertheless, with different speeds, we see this is insensitive to any of the surface variations here. What's also a feature, of course, of the ring and ring shape is that we can weld in all kinds of direction, unidirectional. It doesn't matter, the effect is always the same, even if we are doing different shapes or if we are oscillating. The effect is always the same as it works. You can see a very homogeneous weld seam here with the copper in the middle. Here you can see a very even distribution of the weld seam of the material. We can control the weld width with the ring pretty good, and the weld depth with the center power. So there are some more examples of that coming up, but not only deep copper welding is possible with this configuration, but we can also do thin copper welding, keyhole welding. This is a sheet here that is 1 mil thick, and we are welding half the sheet thickness here. You can see very smooth welding with almost no spatters on the copper material. But what's most important is that in the lower picture you can see the evenness of the weld penetration, how even it is. It controls only 0.5 mil penetration depth with the keyhole welding. And again, over here in the other picture you can see the formation of the width and the depth with the core ring combination, so we can influence this very, very easily. Also from thin material we can go to the thick material, very important for some power electronics that we see, and we are selling the high power arm laser into this area where we get these very thick copper that we have to weld. Electrical conductivity is something that is really important here, and you can see that we are welding up to 6, 7, 8 millimeters with high speed. That's possible. Okay. So yeah, from thin material to thick material, that's all possible here. Yeah, something else is welding of the aluminium. We see here that is a prismatic weld can. Here we have some extremely high demands on welding without spatter, being gas tight and proof, and having a very controlled weld depth. So we cannot weld too deep, otherwise we will cause damage to the material inside, and we have to have a fast enough welding for this. So here you can see the evenness. Also in the lower picture you can see the weld depth, how controlled it is, which is very important that we tight seal this can, but don't damage the inside of the battery cell. Here we have some pictures. Sorry about that. Start again. Here we go. This is some of the weldings that we do to the battery can. So you see a very controlled and very even welding that we have, even around the corners. So very important to have no spatters here and have a gas-tight welding. Yeah, another example for aluminium welding is busbar welding for battery modules. So you can see here the requirement is to weld very, very fast, because we don't want to harm, again, the material inside and the isolators that we have there. So here the task was not to go over 90 degrees. With the fast welding, we reached about 70, 80 degrees here in this example. You can see here the welding. One more slide and then I stop. Dissimilar material, we have aluminum on the top and we have copper underneath. And with a wrong distribution that we see here, we don't get a real good joining of the material. You can see here that this is not very even. The material is not mixing very well. Aluminium has a lower welding melting point than copper does, but if we have the right distribution between aluminium and copper, then we will get a very good mixing of the material. As you can see here in the lower picture, you can only see the aluminium because the X-ray has to adapt to the material which is visible here. But here you can see a very good mixture. Okay. Then my last slide, time is up. Hairpin welding, we see, what we see right now is the welding speed is going down because the volume is going up, so the demands are very, very fast welding. We can contribute to this with the arm laser, where we influence the weld time with the laser power, but to the weld time, or to the complete process time, there are more and more things contributing. So there's a variety of heads on the market. The software is important, the image capturing, the detection is important. So there's a combination of different things. We see welding speeds that are below 100 milliseconds, far below 100 milliseconds, so the arm laser can contribute here. You as a customer have the choice to combine this with the right optic heads combination here. Okay, please come to our table over there in the other area. We will happy to discuss this with you or show you more of these slides and films, of course. And thank you for having me here. Happy to discuss further things with you, and thank you for having the chance to show this here in this event. And thank you.
Thank you, Thomas. Very impressive.
Thank you.
Impressive. Congratulations for those results and for the presentation. Are there any questions? I cannot see questions from the... okay, please, Antonio. Sorry, Antonio, just 1 minute. The microphone is coming.
It's very interesting, the concept to have a dual beam in the fiber. Did you took in account to use now other wavelengths and even to combine two wavelengths, one in the core and a different, for example, blue in the cladding, in the external cladding? Thank you.
For the moment, we only have this near-infrared fiber laser. Other wavelengths are important. I understand this. For currently, we don't offer them, and we are not experimenting with this hybrid version of different wavelengths in the core and the ring.
Thank you, Thomas.
More questions?
Time is over. We cannot have time to do another question, sorry. But I'm sure I will come to visit your stand. Congratulations. So let's move to the second speaker. Second speaker is from Trumpf, Matthias Beranek. Matthias, please, the stage is yours. Trumpf is one of the most important laser manufacturer, so it doesn't need to be presented by myself. Matthias, 15 minutes, then we have time for 1 or 2 questions, please.
I think we have to switch the picture. That's all right. So yeah, good morning, everybody. After 2 years of struggling mankind, I'm really glad that, or to see that the laser community is coming together again, slowly but surely. I got a lot of grounds to cover today, so we'll get started. So laser welding and e-mobility for Trumpf means basically two major technologies, one of which is based on the infrared lasers using special waveguides, which were, by the way, originally found by Trump. So brightline weld is a major technology, especially for copper welding. And the other one is still based on the true disk lasers, from which we generate the green laser light to keep a high brilliance in the beams, to keep the capability of using scanner optics. As you might have heard, most of the applications in the battery, in eDrive, will still use scanners. And this is true for both laser systems. So that's important to know. Another thing which is important in coming with that is actually the welding regime we're in. So the green lasers relate more to what we call heat conduction welding. And all of the rest, with deeper penetrations, will still be done with the high power infrareds. Important. Most of the stuff we're doing is in pre-development. All the application centers we have worldwide. So mainly together with the customers, we're pushing forward what's the demands in the e-mobility applications, where everybody is welcome to join. At the moment, we're hitting 600 trials per month, so you can get an idea what's going on and what's requested. Today I wanted to talk about higher integration. Higher integration happens throughout all our technologies. Basically, I want to start with the green lasers. Through the green lasers, so the visible wavelengths, we have found, of course, that they work especially well with copper. They increase the absorptivity. But once you leave the heat conduction weld mode, we have seen some gaps in between regarding performance and quality of the weld seams we're generating. That's why we added a brightline waveguide to the 3 kilowatt green laser, which, like you can see here, enables to jump in between quality gaps which might still be there. So in that case, the welding depth is already 2 millimeters, where in both cases, green single spot and brightline waveguide, infrared quality became lower looking at the weld seam. And in between that, we were using the brightline system on the 3 kilowatt, which then helped to increase that. So you can think of, in that case, a busbar welding, for example. The green lasers in general prove to be very good in foil welding, I would say. This is the light tower application. You really cannot use infrareds there. And going on a little bit into the thinner bus bars, power electronics contacting, and up to the general industries and copper powder welding. Higher integration also means that we will use the latest waveguides we have, talking about brightline weld, and scale it up even further. So this is an application we get increasingly requested, where it is all about tightness. Helium tightness in many cases. This is true for everything which houses power electronics, like inverters, loading socket, and so on. And what we did here, we added to the brightline weld system and DOE. So in diffractive optical element on the right side, you can see what is the result. So in that case, we would be using 4 spots instead of 1, which especially increases the width of the weld seams, which then greatly contributed to getting that tightness to get to the high specifications. And if we look at some high-speed videos of the process, I think the difference is directly visible. So on the left side, we got the standard multi-spot layout with a relative size of the melt pool. On the right side, you can see the effect of that multi-spot waveguide. So you get a wider seam or a wider melt path in this case, which then leads to that tightness. A side effect of that is that we've seen also increases for the welding of cast aluminum. I think many of you know that this is not easy, even with the laser. And with this multi-spot optics, as you can see, we have created seams which get a high degree of cleanness in terms of porosity formation, so very low porosity formation. The approach here is actually to have a multi-pass weld as well. So it's not a single pass weld, you've seen it, it is repeated, which then allows an even improved outgassing of the pores. So let's say this is the old world, so the pores were even laughing at you in some cases. And with the multi-spot optics, we can see a great reduction of porosities, which is the main problem in cast aluminum welding. So it is quite a great result. Then there will be improvements and even higher integration in the can cap welding. So this is for prismatic cells. This is what's used today, let's say. So welding with a relatively low speed. And what we will do now is to combine the sensor technology in order to exactly determine the weld joint. You can see that it's just a dry run without the laser on, which is quite essential in order to get to what you can see in the final video, using, again, like a bright line single spot process, but then be capable of getting much faster. So that's 3 times at least the productivity we have today. And this is what's possible with that combination of a weld joint detection and a scanner weld. So that's the cross sections. Welding depth here was 1.3 millimeter. And the uniformity of the weld seams all around the can is actually quite high. And then I go to the higher integration part 3. This is the hairpin welding, which has certainly grown quite mature. The main application here is, of course, the contacting, the welding of the pins, regular pins, as well as the face connectors of the E-drive. We're doing this for 5 to 6 years now, practically every day. There's an installed basis of more than 350 high-power lasers from Trump for both the welding and the ablation, which is the preparation process of the happening before the contacting. And for that, it has been a great time. What you can see here, just if in case you haven't ever seen a hairpin weld, that's a high-speed video of how it's carried out. So usually you will use the scanner, which creates a certain shape, a wobbling movement on top of the pins, which then will create the melt pool. It's important to understand for everything I will say afterwards. By the way, welding times at the moment are around 100 milliseconds for the typical cross sections. So this uses high power infrared lasers, most of the cases with the bright line system. The reason for that being 2 things in the first place, one of which is better formation, which is more relating to the manufacturing side of things, talking about keeping the machines clean, and also do no damage to the windings of the motors. So you can see basically that for certain pin geometries there will be an adjustment of the ratio because the power is distributed to the 2 spots. Where there is a low level of spattering, in that case I would say like with 40% to the core. And I think even more important that if the copper is showing porosity formations or a tendency to do that, Brightline will also help you to that increased melt pool, let's say, keeps the keyhole open a little bit longer. For that we have an improved degassing of the pores. There's 2 very typical setups at the moment. working mainly through the spot sizes. So if you take a look at the upper path, this is the short focusing length, relatively small spot, but enables high intensities in terms of megawatts per square centimeter. And this is the most important thing for copper welds in general, I would say. Rule of thumb or boundary would be to at least have 10 megawatt per square centimeter in order to get deep penetration welds. And so the upper part is the most important or the most interesting one for getting very fast welds, very fast melt formation, and the fastest welding times in consequence. Whereas the lower path is very attractive for machine concepts, as it would offer a large, what we call working field, but will be a little bit slower in the execution. So born with the hairpin application was that you will use a distinctive process in combination with a sensor technology. In that case, we have to cover dislocations of the pins which still occur in a fixture, even if in proper fixtures, and try to level it out or have cancellation strategies, easiest case. So we will measure the outer contours of each and any pin, even before the weld is starting, in order to deal with the problems which might occur. In the production solution, we will of course not measure pin by pin, but go to group measurement strategies, this is how we call it, in order to bring down the measuring times as they will add up to the welding times. And then there's two things. For the various dislocations we can have, we have the left side, which is a simple alignment of the weld path. More interesting is actually the right side, where it's not enough to just align the weld path. There we have to change the welding strategy and whatnot. And this is what the sensors can do. So they will take the measure results and determine which welding strategy has to be used, which gives you something like that. So left side is the reference weld in a zero gap condition. The middle picture shows what's happening if you do not use an active compensation strategy. And on the right side, we have just used a different welding approach based on an automatic call, which was based on the measure result. So it is to contribute increasing the robustness of the welding process itself. Another thing is that for the sensor systems, they're of course having their weaknesses. This is something which today happens in the ppm range of failures. So imagining the mass of welds we have to do, especially looking at larger volumes of e-drives, there will be that there is false measurements, because this is picture acquisition, this is grayscale evaluation of the pictures, and on the left side it practically shows what could happen in some of the deviation cases, so it's a false measurement. And what we are transferring to or transitioning to is to replace that grayscale evaluation by artificial intelligence, which is pattern recognition and which is meant to even increase that ppm range failures down to zero. It just works great. It gets you independent of contrast conditions on the parts and whatnot. So this is the next step in technology, which will be just great. And then talking a little bit about tailored setup. As you can see, I got two different welds here with a relatively small geometry of the pins. And this is the two different spot sizes, let's say. On the upper side, the smaller one, which results in the highest strength, right? The weld could practically also be done with a larger spot, which takes a little bit longer to weld. And the more energy you put into those hairpins, the more you weaken the structure, which means you reduce the weld, let's say the joint strength. And that's the reason why, looking at individual pin geometries, we will always select the correct setup in the first place in terms of spot size. And then if we go on, the same happens for the distribution of the power to the multi-spots. So you can see this is also something which needs to be taken into account in order to improve and increase the joint strength. I'm almost done. So at the moment there is, let's say, a discrepancy between what we want to have for a perfect welding process, like for example using very small spot, and what the machine concept might want to have, a large working field. And to bring that together, we have created the possibility to, let's say, unite the two possibilities into a multi-optic concept, which will in addition increase the cycle time quite a lot. So if you look at the video, this is how it's working today. The measurement, this is done up front, like I told you. And then the welding is carried out, what you can see here in red. And then we even have to split it to 2 times in the stator. So this is how it's working today. And if we now go to dual PFO concept, we will be capable of using the measurement values of one optics for the other one. So this means a deeper and higher integration to the system. And then we can pretty much cut down the overall cycle time. And it's especially impressive and interesting for like large stators, which are quite standard. So if you pay attention on the left side, we have always some mechanical movement in order to get the next hairpins into the working field. On the left side, you will see more or less just one mechanical movement, and then the rest is done by the optics and the measurement algorithms. So now we're finished on the right side with the dual optics, and the other one is still working. And the gain here, in that case, was around 30%, which is massive, given the fact that until today we were always working on optimizing the welding times themselves. And now this is just something which is coming out of the system and already giving a very high benefit in that case. So I want to leave you with that. I'm even 2 minutes early, so there can be a lot of questions. Thank you very much.
So for being on time, thank you very much, and congratulations for these new research results, very impressive. Are there any questions from the audience? I cannot see questions from the people connected on internet, so please, Gökhan.
Thank you very much, Matthias. It's actually good to see you after 2 years, right? So,
yeah.
Congratulations on everything that we've seen so far. So you also showed the importance of integration, not only the laser. But I have a laser question, being a laser guy.
That's okay for me.
Yeah. So you showed a nice graph with green lasers, and it's very nice to see that we have commercial green lasers. Near infrared, green, 3 kilowatts, bright line, single, right? But the green laser is essentially an infrared laser that is converted. So the question is, if we increase the power of the infrared laser, do you have comparable results from that point of view? So a high power infrared laser against a high power green laser, how do they compare?
I think they are quite hard to compare in the first place. You have to have the use case in like very, very demanding applications for infrared at all. And it's quite right that if you had the 3 kilowatt green, this would mean that you would have an original 6 kilowatt infrared, right? And if I go to compare that, we usually have totally different applications where, you know, there is not a 6 kilowatt green laser at the moment, for example, to compare to a 6 kilowatt infrared. And so it's a little bit tricky, but I would say where the use cases differentiate is really there is a very high welding depth, for example. Very high is already above 2 millimeters, talking about copper, as it is hard to get into that material, right? And this is where it becomes more and more independent from what wavelengths you have. As we, the deeper the keyhole gets, the more we get into multi-reflection mode, which then pretty much equalizes which wavelength we're working on. And for that, but this is my personal opinion, I would always use an infrared laser because it's lossless, because it's the same pricing in the end. If you've got a 3 kilowatt green, it's a 6 kilowatt, this is something you can work with. And so for that, we really have to look into the use case. So to cut it short, I think there is not a comparison which makes sense at the moment, because the use cases just differentiate, or else the visible lasers will be used where the infrareds have real problems right from the beginning.
Thank you, thank you. I think we have to move to the next speaker because we do not have time, and for other curiosity or information, you can go to the stand Trumf on the other part of the Golinelli. So it's time to call Stefano Cattaneo, my friend Stefano, so thank you for being here. Stefano is one of the most important person in EPG, so I'm sure that he can show us the latest news also from EPG. Thank you, Stefano.
Thank you, Alessandro, for the introduction, and thank you for having invited me and IPG to participate to this event. It's really good to meet in person and to be here today. So, the topic is very interesting and also very wide. It's almost impossible to touch all the aspects, all the applications of the lasers in the e-mobility field, because there are really a lot, as Alessandro was saying in his presentation. So I found myself in front of this slide saying what I should talk about. Let's say in the previous presentation, we have seen only or mostly welding, but there is not only welding. Here there is a list, but it's not even complete. There is no cleaning, there is no foil structuring. So I tried to, let's say, to work and to present mainly how IPG works in this field. How is our approach to the problems coming from the customer? Because if we consider, for example, the slide that Alessandro was showing with the laser producer or machine producer and the arrow to the end user, we prefer to see this in the other direction. So we are provide a solution for the end customers with most often the university in the middle. So from my point of view, from IPG point of view, the arrow should be made in the other direction. So when we receive a request from the customer, we start understanding what to approach the problem. So the customer is coming with a problem, but the laser is not a universal tool. There is not only one laser for doing everything. So we start understanding what is the best laser for that specific applications, for that specific problem. So the lasers differ in terms of wavelengths, for example, and we have seen in the previous presentation that other wavelengths is not only infrared, other wavelengths are interesting for these applications. But also lasers have different characteristics in the time domain. So we can go from CW, where simply you switch on the laser, fire the power, switch off, and the laser stops. Or you can move to the QCW lasers with millisecond pulses, with high peak power and low average power, or down to nanoseconds, few nanoseconds, picoseconds, or femtoseconds, and the results of your material, laser material interaction is completely different. So this becomes even more important if we work with, let's say, high reflective materials, difficult materials like copper or aluminum that are the most popular in the e-mobility world. If we consider the copper, for example, and we start understanding it's better to work with the visible radiation or the infrared radiation, because the two solutions are different and gives different results. So if we consider the absorption, the initial absorption from the material, it seems that the visible is better because the absorption is definitely higher in the visible range rather than in the infrared. But if we consider what's happening on the material as soon as we start the laser, the situation changed immediately. In less than 1 millisecond, the absorption changed dramatically. As soon as you move from the, let's say, from the room temperature to the, let's say, heated up material or to the melted material, or after the creation of the keyhole, immediately the absorption increases dramatically and with significant benefits. So again, we have to decide what is the best laser for the application. So IPG is producing a lot of lasers. Everyone knows IPG. IPG is the world leader in the fiber laser, the first introducing the fiber lasers in the industrial market. And we are currently have, I think, the most and let's say, the best laser product portfolio with lasers scaling up to 120 kilowatt CW. Actually, we also got an order for 125 kilowatt CW, but down to short pulses, picoseconds, femtoseconds, UV to mid-infrared, so a lot of opportunities. But laser alone is not enough, so we introduced different possibility for different optics, so you can get very small spots, single small spots, or multi-mode or different beam. Or we introduced also the optics, the heads for the process, so scanning head, wobble head, because the laser alone is not enough. But at the end, what is important for the end customer is not how the laser works or how the laser welds its parts. The important is how well the parts are welded. So we introduced also the monitoring option, because at the end it's important to have a reliable production, a stable production, high quality production. The mostly used laser in the e-mobility field is the AMB. It is similar to what you already seen before, but this is nothing, let's say, strange, because at the end it's good that we are all ending on the same solution. So the adjustable mode beam is a combination of two lasers, two totally independent lasers, one in the core and one in the ring, with the possibility to have in the core the real single mode. Real single mode means 10, 15 microns fiber. And we can have, in principle, any power. We are delivering single mode laser up to 10 kilowatt, but in this case, 2 kilowatt is the perfect dimension. In the ring, we can have almost any power, but also we can have any fiber dimensions, because you know, IPG is very vertically integrated. We are designing and producing our own fibers, so this allows us to design the solution that we think is better for the customer need. And the benefits of the AMB we have already seen, the better quality, better stability of the process. We also tried to give an idea why the AMB brings better results. That means mainly sputter-free and better quality. It has been well explained, so I can save some time for my presentation. So at the end, the ring added to the beam allows a better stability of the keyhole, a better dynamics of the gas pressure inside the keyhole and of the weld pool, generating let's say, a very stable result. You see here the comparison in the same application with the standard beam and with the AMB. So speaks alone. So as said, we have two completely independent lasers with a single mode in the center, because the single mode is important for having high power density, so deep penetration, deep, let's say, very high quality deep welding, and any combination of the core and ring. So if we compare this solution with the visible, the green and the blue, okay, we can agree that there is a better absorption at the beginning, but as said, this is just for the first millisecond of operation, hundreds of microseconds actually. But at the end, the infrared radiation is something well-known, well-developed, available in any power optics combination, definitely more convenient, cheaper, more reliable. So at the end, from the point of view of the end customer, that has, let's say, for the end customer, what important is the production. The infrared radiation is normally the best. We are not saying that the visible has not some advantages, but not here. Then if some customers, we have also a green and blue laser. So if customers comes asking for a green laser, we can sell a green laser. But if customer comes with a problem, we prefer to deliver a solution. Then other important aspect is the monitoring of the production. Again, it's not important to weld, it's important to have good welds. And IPG has been the first introducing the direct measurement of what's happening on the workpiece. So we are not measuring the radiation coming from the workpiece. We are not trying to understand what's happening, analyzing the reflected light or the, let's say, diffused light. We are directly measuring what's happening there. And there means before the weld, after the weld, but also in the weld. So we are measuring for each single weld the penetration depth. And this is giving a lot of information. And also gives the customer the confidence that the quality of that specific single weld. And if you consider a battery where you have hundreds of welds, it's really important to have all these hundreds welds well done. And if something goes wrong, you know what specific weld was wrong, and you also know why it goes wrong. But what even more important is that you analyzing the statistic of your welds, you can understand if your process is somehow derivating. And then you can adjust the process and bring back to, let's say, to a stable process. But again, even more important is the possibility that in the design of your production, you can, from the beginning, foresee a second weld in case the first one goes wrong. So if your weld, you are going to perform just one weld, and the weld, let's call it A, goes wrong, you can immediately, the system can decide to perform a second weld, the weld B, and move to the next weld. So your defects number is dramatically reduced directly from the machine. The solution can be used also in the R&D phase because you immediately know the results of your weld. You know the penetration, the stability of your process, so it gives enormous advantages. But there is not only welding. So we have also the foil cutting that is extremely interesting. still not so popular in Europe, but is becoming more and more popular because Europe wants let's say, independence from Asia for the production of batteries. So consider that last year, only for this application, we delivered to China more than 4,600 lasers, only for this application. So cutting of the foils, some examples, some results, the cathode, the anode. And we have seen that the faster, the better. So as fast you go, as better is your result. So we developed new laser for this application. So because the existing lasers were not enough for the productivity and also for the quality required by the market. So we released new modules up to 500 watt nanosecond, air-cooled, because for some application the water is never accepted. So we had also to develop the air-cooled version. Or nanosecond lasers up to 1 kilowatt, 2 kilowatt. That is something not existing, but for this application was necessary, so we developed the solution. Or for low-speed cutting, we are using also the picoseconds up to 200 watt, because at low speed gives also good results. So for any applications, we can find the right laser. But there is also something new coming, that is this laser structuring of the battery foils, where we have to create some criteria on the surface for, at the end, making the charge and discharge of the battery faster and more efficient. Again, here we are using the high-power nanosecond laser with a repetition rate up to 2 or 4 megahertz. Each pulse is a criteria, and you see the result on the material. But as said, we are providing customers solutions, not only lasers, not only hardware. So we developed this integrated laser welding system that puts together all the parts from IPG. So you can use any lasers from IPG, any optics, scanning, wobbling, any optics, together with our control, our software, our complete control of the process. So this is mainly used for welding the batteries, the bus bars, but also for the hairpins. So with this setup, we can weld a stator from the single position. A stator up to 230 millimeters in diameter can be welded from one position of the head without repositioning. With the new lenses, with a 500 millimeter lens, we can weld from the same position a stator up to 250 millimeters. But also, we are now introducing machines. So machines means small machines like this that can be used for R&D or for the production of small battery packs. Everything is inside, so all the IPG technology is inside. You can have any lasers, any optics, the LDD monitoring functions, everything. Or the high productivity version, these machines already installed in the production of battery modules, so with let's say a battery module in 100, 150 seconds, depending on the module, where everything is inside. Or the robotic approach. Robotic is not the preferred solution, even if the robotic approach is more flexible than the Cartesian approach, but is considered not precise enough, not good enough. But in the reality, it's not true, because if you install the vision, if you install the scanner, then the optical parts bring the precision needed for the application, and you can keep the flexibility of the robot. So we have both the solution. This is not the preferred, but according to us, because it's not understood yet completely. But IPG, especially in the US, introduced also complete production lines. So we can support the customer with a complete line. Here, there is some, let's say, there is the video of the line. What interesting is that around the 50 seconds, you see the LDD, how it works. So for each weld, the LDD is measuring the zeta position, if it's correct or not, and check the welds that are performed and gives the green light if it's correctly done, or the red line if it's not properly done. I don't know if we can make it faster. But let's arrive to see at least the LDD working. Yes, I'm finishing. Okay, you see here, for every weld, after the LDD make the measurement and give you the feedback after each single weld. So in summary, IPG has a unique portfolio of lasers. IPG has 26 application labs all around the world. Here in Italy, I think that our lab is the most and best equipped laser lab in the country. But we have labs everywhere, and 2, 3 are coming in Poland, in other countries. So we think that IPG is changing the paradigm of the laser. The laser, everyone knows, was born as a solution looking for a problem. Now we are saying the laser is the solution for your problem, but it is important to have a partner that helps you in understanding what is the right laser. And this is what IPG is doing, especially in a field like the e-mobility, where the development is so fast. So if you install a machine today for welding a certain battery module, tomorrow you will probably be required to perform something different cells, different materials, different thickness. So it's not that simple as it was in the past. Okay, I finished. Thank you.
Thank you, Stefano. Sorry. Because the coffee break is very close, so this is the only reason why I stopped you.
Thank you.
So, do you have any question for Stefano? Yes, please, Johannes.
Thank you very much for your interesting presentation. I have one question concerning your fiber-based picosecond laser. I think you have it up to 200 watt more or less. And my question for you is, what chances do you see that you have a picosecond laser fiber-based? Thinking of equipment manufacturers and also of end users, what advantages do they have in terms of integration into their production equipment? And maybe this is also a chance which makes it feasible for, let's say, battery foil cutting, for example.
Yeah. As I was saying, we have seen that in the foil cutting, the faster the better. But sometimes the limit is not the laser, but is the scanners, the head itself. So if the speed is limited, then the picosecond, even at low speed, can give, let's say, better results. And this is why we are using up to 200 watt average power. We are testing a kilowatt average power picosecond laser, and we were expecting to get, let's say, the best quality at the highest speed. It's not exactly like this. There is still some work to do, but in principle, the 1 kilowatt picosecond laser is already available and possible to deliver, no problem.
Okay. Thank you, Stefano. We do not have time for another question. Thank you again for sharing your new knowledge and new results. Thank you, Stefano. Now it's time for our first break. The break is on the building just outside of this building. And for people who are following this conference on web, we will start in 30 minutes because we are a bit late. So 30 minutes for a coffee break and to restart here. Thank you and see you later.
who do the application at the customer side, but also do the support if something is not working.